Hello everyone and welcome back to episode 3 of Science at Home with me, Dan Nickstrom. So if you remember a couple of episodes ago, we talked about how a speaker works. Yeah, we pulled it all apart and we figured out how a speaker actually vibrates by taking in electricity and creates the exact same vibrations in your room as the air is vibrating here in my room. So it translates those vibrations into vibrations in your room. But we missed something really important. We didn't talk about how the vibrations from my voice get recorded and sent to you. So there's a speaker that you're listening to on your end, but there's a microphone on my end. So somehow a microphone records all these vibrations, and then there's the electrical signal that's sent to your speaker. So today we're going to figure out how a microphone works. How are you able to record the sound in the first place before you play it out to your speaker? Now, to fully understand how a microphone works, we have to understand how electricity works. We're going to do that two different ways. The first way involves potatoes. Lots of potatoes. And it also involves some nails and some money. Particularly, we want to talk about coins, coppers. What I'm going to do is, I'm going to insert a nail into this potato and a copper into this potato. I'm also going to insert a nail into this potato and a copper into this potato. And I'm going to carry on doing that to all of the potatoes. People are complicated, but that's got consolation. Okay, so I've put a nail and a coin in each of my potatoes. You're probably wondering, why am I shoving all these coins and nails into spuds? Well, believe it or not, what I've created here is a battery.
Spuds? This is me dinner! You call this
Quiet,
science?
you! This is a battery. Okay? I'm going to connect all of these up together and I'm going to create a voltage, and we're going to see it here on the oscilloscope. And that's a battery. Here we go. So I'm going to connect the copper coin on one spud to the nail on the next spud. It's important that the copper of one gets connected to the nail on the other. And then I'm going to connect the copper of this spud onto the nail of the next spud. And then the copper of this spud onto the nail of the next spud. And I'm going to continue with that same pattern, copper connected to nail. Now these nails, they're not that special of a nail, but they have to be a galvanized nail. Now your parents should be able to explain to you what galvanized is. It's just this particular coating that's put onto metal to stop it from rusting. So you'll have all sorts of things that are galvanized. And that means if you galvanize something, you coat it in zinc. So we have zinc coated nails and we have copper coins. Okay, so we've connected all of our spuds up together. Bonus points for whoever saw my mistake. I connected a coin to a coin and the battery wasn't working. But now we're going to prove that this is really a battery when I fix it all up. So to prove it's a battery, I'm going to use a real battery first. And if you remember from our first video, this little dot here, when it's in the middle, it means we have 0 volts. When we connect the battery, boom, we see a voltage. So this is a 1.5 volt battery. You'd see them all around your house. You see it's positive on one end, negative on the other. That's a battery with a 1.5 volt output. So let's see what happens when we connect to our spuds. So I'm going to connect one end to this nail, this zinc nail. I'm going to connect the other end to this copper coin. And watch the dot. If the dot moves, we have a voltage. Boom! Look at that. Look at how big that is. That voltage. Let me connect it here. That voltage is way higher than our actual battery. Okay, so we have a voltage that's 5, 10, that's 12 volts. We're getting 12 volts of electricity just by connecting all these potatoes together with the copper coins and the zinc nails. So we have built a battery, a pretty strong battery at that. Let's see now if we can power anything with this battery. I'm going to connect this little LED, just like what you would have in any of your lights. And if we look here, when I connect this LED, look, we have light. Potato powered light. This LED is lighting up purely by being connected to potatoes. So how are these potatoes making electricity? Well, the important thing is that there's a chemical reaction between the electrolytes in the potato and these copper coins, and the electrolytes in the potato and the zinc nail. And those two chemical reactions are different. One of them makes a positive charge and the other one makes a negative charge. And you might have heard of electrolytes before. Drinks like Lucozade Sport, things like that have electrolytes in them. So you can do this with potatoes, with lemons, with oranges, kiwis, bananas, any fruit or vegetable you can play with and you can build into a battery. You just need zinc and you need copper. So that's how batteries work. Now we're going to look at how to generate electricity in a different way. So we know we can make electricity by making batteries. But there's also another way to make electricity. You know all your devices have batteries in them, yeah? But usually then you charge them and you plug them into the socket in the wall. Or maybe your kettle's plugged into the socket in the wall. But where does that electricity come from? It doesn't come from batteries. It comes from a power plant. So how do they make electricity in a power plant? Well, they make electricity in a power plant using the three things I have in front of me here. A coil of wire, wire wrapped round and round and round, around a little pipe like this, just something to wrap it around. A little metal object, something that we can spin around, something that we can easily twist and turn. And then some magnets. That's all you need. Magnets, a coil of wire, and something you can spin around. And here's one I prepared earlier. So the magnets are inside and we can spin them round and round and round. Just by turning a magnet inside a coil of wire, we can generate electricity. That's how they do it in power plants. You can turn a magnet inside a coil of wire or turn a coil of wire inside a magnet. Either way will create electricity. But you can't just take my word for it. We have to prove it. So we'll prove it by connecting up to our oscilloscope. And of course you'll remember at this stage that when you connect to an oscilloscope, you watch the little green dot in the middle. And if the green dot goes up or down, you have a voltage, which is how we measure electricity. So let's start turning. And look, there we go. We're creating electricity. Look at the voltage. It's going positive, negative, positive, negative, positive, negative. So that's an alternating current. And that's the type of electricity that comes out of the plugs in the wall. It goes positive, negative, positive, negative.
You think you could spin it a bit faster than that?
Quiet, Chew. Sorry about that. Now that you know how electricity is created, you're going to be able to understand how a microphone works. So remember we talked about the speaker. And we said that electricity goes into the speaker and that creates a magnetic field in this coil of wire. When electricity goes through the coil of wire, it becomes a magnet, an electromagnet. And that causes it to vibrate because it's inside another magnet. So it either gets attracted to it or pushed away from it. And that is what makes our speaker vibrate. Yeah? So the microphone is the exact same, but in reverse. So a speaker can be a microphone and a microphone can be a speaker. Inside your microphone, there's just a really, really tiny speaker. So what does that mean? Well, that means if you talk into a microphone, it causes the paper to vibrate, which causes this coil of wire to vibrate. And like we said, when a coil of wire moves inside a magnet or a magnet moves inside a coil of wire, it creates electricity. So let's double check. Let's see if it actually is real. I'm going to talk into this little speaker that's basically a microphone, and we're going to watch and see if I can create any voltage. Ha ha, do 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 ha. There you go. We created a voltage. Whenever the green dot moves, we have a voltage. So when I say 2, 2, ah, testing, 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 we can see a voltage being created. So now we understand how a microphone works. I talk into the microphone, it causes it to vibrate, which creates electricity because the coil of wire moves in a magnet. That electricity goes through here and is recorded. Then if you play that exact same electrical signal back through another speaker, that will make that speaker vibrate and the exact same vibrations will come out. So you can see a microphone and a speaker are the exact same thing, just in reverse. So I hope you learned something from that and you can connect that up with the earlier video, and now you have a real understanding of electricity, how to create it, and how that is all involved in how speakers and microphones work. So thanks so much for joining in, guys, and I can't wait to see you on the next video. Bye bye.